So what does the SCR catalyst actually do? Well, it does quite a few things, actually. First of all, the SCR catalyst holds evaporated DEF like a filter. So the evaporated DEF is essentially when the urea or the DEF fluid, the DEF fluid is injected into the decomp tube, it's going to start to evaporate the water. It's going to be hot enough in that assembly that the water will evaporate from the urea. And then the urea, once it exceeds roughly 400 degrees Fahrenheit, will start to change its composition. The urea molecule will slowly convert into, actually really quickly convert, but it will convert into ammonia. That ammonia will attach itself to this first substrate here. Notice there's two substrates. So the first substrate is going to be your SCR oxidation catalyst. It's going to be your NOx oxidation catalyst, right? What this is going to do is your urea that converts to ammonia, well, the ammonia molecules will attach themselves to the wall of the substrate and wait for NOx molecules to come floating by. Once the NOx molecules float by, the ammonia molecule will attach itself to the NOx molecule and neutralize it. It's going to turn it into dinitrogen, a little bit of carbon monoxide, and water. Now that NH3 sensor I was talking about earlier, that ammonia sensor, would be mounted in between these two, because what it would be measuring is how much ammonia passed through this catalyst and did not neutralize NOx. So the second catalyst we have here is an ammonia slip catalyst. This catalyst has a different composition, which would neutralize any ammonia molecules that did not attach themselves to NOx molecules in this first catalyst. That ammonia molecule will pass into the ammonia slip cat. It will neutralize that and turn that into dinitrogen and water. Okay? So again, as the oncoming exhaust floats by, the DEF reacts with the molecules in the exhaust to form new, less harmful compositions. The resulting output is water, non-harmful molecules, right? So CO2, dinitrogen, and water. Now we also have SCR inlet and outlet temperature sensors. Not all manufacturers use those again, okay? Most of them do. But we need to be able to tell what the temperature inside the SCR catalyst is. There's a few reasons for that. One, we need to make sure that our after-treatment system is hot enough to actually do something with NOx, okay? If we're not hot enough in our exhaust stream, we're not going to be able to take the DEF fluid that's being injected, evaporate the water, and then have the urea molecule convert into ammonia. Okay, so we need sensors to be able to measure the temperature down there. And then again, some manufacturers use that ammonia sensor, or NH3, again, NH3 standing for ammonia. That's going to measure how much ammonia slip is occurring in our NOx catalyst here. Then, of course, we have NOx inlet and we have NOx outlet sensors. Those are going to be what's measuring how much NOx is coming out of the engine compared to how much NOx is coming out of the exhaust to let us know if our efficiency of our catalyst is any good. So as a general rule, again, general, NOx inlet sensors will be mounted close to the engine, very close to the turbocharger. They're 4-wire sensors, okay? But I've seen them as far back as right after the DOC. So they do come in different locations, but behind the turbocharger is the most common. The NOx outlet is mounted at the very end of the after-treatment system, right where it goes into the exhaust stack. So it's mounted generally, I'm going to say maybe 4 inches after the SCR catalyst, right? It's going to be a 4-wire sensor as well. Now, be aware that when you're dealing with 2018 or newer vehicles, on the outlet of your exhaust stream will be 2 sensors that look very similar. One's going to be a NOx outlet sensor. The other could be a particulate matter. Okay, now particulate matter sensors measure how much particulate is passing through the DPF. So it has a whole different reason that it's there. But on your NOx outlet, 2018 newer, you might see 2 sensors side by side. One's going to be a NOx sensor. One's going to be particulate matter. So if you have to diagnose one, make sure you're diagnosing the correct sensor. Okay. All right. So operation. What I want to do is I want to kind of take you through how do we troubleshoot this, right? Like I've told you a lot of stuff about how these components are, right? How they're made, what they do, and that's good. And you need to know those things. But when it comes to SCR below efficiency, below threshold, we need to figure out how to fix that. You guys hearing me talk doesn't help you fix it. You came here because you want to learn some ways to get through this. So let me kind of take you through how I do it. When I'm in the field or when I'm troubleshooting somebody's truck or helping some old buddies of mine that work on stuff or whatever the case, there's a flow chart that I have kind of come up with that just really works for me. And I think it's going to really help you guys too. So what I'm going to do is I'm going to jump over to a tablet and I'm going to start doing some drawings. Now, I want y'all to bear with me because my my drawings are terrible. They're terrible, right? But I hope it helps you kind of get the idea of what we're doing. All right, so up here I'm going to draw just a really small version of a DOC and a DPF because we're not really talking about those today too much. What we're really focusing on is the SCR, right? Let me actually move that a little bit so we can see a little bit better. Now this pipe here, we're going to say this pipe up front is going to be my downpipe coming from my engine. So depending on the model, there may be a hydrocarbon doser mounted here, but you'll also see your NOx inlet sensor. Okay. Then we come into our DOC and our DPF, and then we come out to our decomp tube. Okay. Now I'm going to draw the second component a little bigger here. Now, if this is our SCR catalyst here, then we may have an SCR inlet temp and an SCR outlet temp. We might have, and again, not all manufacturers used it, but some did, the NH3 sensor. Then, of course, we have a NOx outlet sensor located here. Okay, this going to atmosphere. Then here, we will have our DEF doser. Now remember, inside of this we had two different catalysts, right? So I'm gonna kind of just highlight where the two catalysts would be. And again, SCRs are generally not serviceable. They have to be replaced, right? So we'll say that these are our two catalysts here. So this will be our ammonia slip. So I'll actually just write NH3 here. NH3 slip. And then this is our oxidation catalyst. Now, what does low efficiency mean? What does it mean when it says NOx conversion efficiency below threshold? Well, basically what happens is manufacturers give you, as a general rule, an 80% efficiency. Now, some manufacturers have a 70% efficiency, but 80% is the most common efficiency. What that means is if my vehicle has an 80% SCR conversion efficiency, that means once I drop below 80%, I have a problem, right? So what does the 80% mean to you? It means if I had my NOx inlet compared to my NOx outlet measurement, my NOx outlet needs to be 80% less than my NOx inlet when my DEF doser is commanded on. So for an example, NOx sensors generally are going to be broadcast their measurement in parts per million, ppm. Okay, so we need to understand that when we're looking at conversion efficiencies, we're looking at the NOx inlet sensor, comparing it to the NOx outlet sensor, and we're going to be using parts per million. So let's say we're cruising down the interstate, or we're in a bulldozer and we're moving some dirt. Either way, it doesn't matter. When you're doing NOx conversion, when you're trying to figure out, is my conversion efficient, what you need to do is put it in a mild duty cycle. You don't want to be putting this thing to the floor, giving it everything it's got. You want to be doing work, but not working its butt off, right? So like a light duty cycle. So an example of that would be if you're in a semi-truck and you're pulling a trailer, you'd want to run roughly 60 miles an hour on as flat a ground as possible with the cruise control set. So you'd probably be around a 40% duty cycle at that point, maybe 50, maybe 60, depending on how much load was in the trailer. But if you're on flat ground and you're doing 60 miles an hour with the cruise control set, then your engine's not just revving up and lowering, revving up, lowering, duty cycle's not going crazy. You're in a consistent rate of work, right? Where you're doing work, but you're not overdoing work. And what needs to start happening is you need to start watching your EGR valve. That's kind of a good place to start, because what happens is when you give a vehicle full throttle and you command maximum power or maximum boost, your EGR valve is going to close. Because if my EGR valve is open, then I'm allowing too much exhaust gas to escape, which in turn is going to slow down my compressor wheel of my turbocharger, which in turn is going to slow down how much boost pressure I can actually build, how fast I can build that boost pressure. So when you start seeing your EGR valve open, that's a good indication that you're at a moderate duty cycle. You won't see your EGR valve open if you're wide open throttle pulling a lot of weight. That EGR valve is going to close, which means there's no exhaust gas recirculation taking place, which means the nitrogens of oxide inside the cylinder are going to be extremely high, which means your NOx inlet sensor is going to have an abnormally high reading, right? But that's only going to be temporary because nobody runs it wide open throttle all the time, or I can't say everybody, but most, right? So let's say we're in a steady rate of work. Let's say the EGR valve is open, and let's say the engine is working correctly. At that steady rate of work, say 60 miles an hour, cruise control set, pulling a trailer, you're probably going to see somewhere around 500 part per million at the NOx inlet. Now, another fair warning, your NOx sensors will not read immediately. NOx sensors have to have an internal temperature over 1,000 degrees. Internal temperature. Now, NOx sensors have integrated heaters just like oxygen sensors, things like that. So in order for that NOx sensor to measure NOx, it has to be free of oxygen. So there has to be an integrated heater to get it over 1,000 degrees. So one thing that I always recommend to people is if you get to the point where you have to drive a vehicle to look at your NOx conversion, I would run a regen first. And there's a couple reasons for that. One, it's going to pretty much guarantee you that you won't be running a regeneration while you're driving the vehicle, test driving the vehicle. Two, it's going to give that exhaust system plenty of time. It's going to give those NOx sensors plenty of time to get hot enough to start reading. So if you ever notice, when you turn a truck on for the first time in the morning with NOx sensors and it's cold, if you ever go to monitor your NOx sensors, they'll say warming, reading not stable, NOx sensors off, -100. There's all kinds of different terminology that you'll see. Basically what that means is the NOx sensor is not hot enough to read. And until the NOx sensor is hot enough to read, it's not going to read. Okay, so you're not going to get a value there. They do that so you're not, misreading the data. So one thing that I always do when I have an SCR efficiency issue, if I get to the point where I need to drive it, I run a regeneration first to make sure that the after treatment system is regenerated, but more or less because I want enough heat in that exhaust that my NOx sensors are reading and they're functioning. So if we've done that, and I'll get to the step-by-step here shortly, but before I do, I got to explain all the things that are going on. Let's say the sensors are warmed up. Let's say I've run my regeneration and I'm to the step where I need to drive the vehicle to validate if my efficiency is truly that bad. If I'm running 60 miles an hour with the cruise set, pulling a trailer, what I would see is roughly 500 part per million on the NOx inlet. Now that could vary a little bit, okay? But you're going to see it somewhere around that 500 mark. 375 to maybe 675, somewhere in there. 500 is a pretty standard value that I've seen doing a lot of test drives. Now, if I have 500 part per million coming out of my NOx inlet, which means coming out of my engine, and my DEF doser is dosing DEF fluid, I must be dosing DEF fluid. If my system is 80% efficient or greater, then I would see the highest number I would see at my NOx outlet while monitoring it would be 100 part per million. That's the highest number I could see and still be efficient, because that's exactly 80%. Now, once I drop below 80% for an extended amount of time while the DEF doser is dosing, let's say my DEF doser is on, and I've got 500 coming out of my engine, then if I had, say, 120 part per million coming out of the NOx outlet while the DEF doser is dosing, and it does this for a long time, then that tells me I am less than 80%, which tells me I'm going to see a fault code here at some point. Now, the one piece of advice I can give you, when you're dealing with SCR-related issues, whatever you do, don't go looking for trouble, okay? What a lot of people do is they say, well, I'm going to go check my SCR. If you don't have a fault code directing you that you have an SCR issue, just leave it alone. If you don't have a fault code for SCR conversion, then leave it be. Don't go looking for trouble. If you have an SCR conversion fault, if your SCR system is not working like it's supposed to, guess what? You're going to get a fault code for it, because that is EPA mandated, right? Now, here's the thing. Cruising down the interstate, the DEF doser is dosing, and I see consistently, let's say I'm worse than 80%, right? So again, if I had 500 part per million coming out of the NOx inlet, then the maximum I can see coming out of the outlet is 100, because I have to be 80% less on my outlet than my inlet. Now, Detroit runs on a 70% conversion. Most manufacturers run on an 80% or greater. And let me tell you this, being a dealership tech, I was lucky enough to be able to test drive brand new trucks and log this data. And I'm going to tell you this, if I was cruising down the interstate in a brand new truck with a brand new Cummins or brand new International or brand new Mitsubishi, it didn't matter. If I was cruising in a brand new truck and I had 500 part per million coming out of the NOx inlet, I would generally see 0 to 10 parts per million coming out of the NOx outlet while the DEF doser is dosing. How good it is, it's almost 100% efficient. Okay, so you shouldn't be 80% efficient. You should be 95% or greater. But you have up to 80% before you start having fault codes. I hope that makes sense to you. So with that being said, If I'm driving down the interstate and I have 500 part per million come out of my NOx inlet, and I have, say, 40 part per million coming out of my outlet while my DEF doser is dosing, I'm happy, okay? I'm happy as can be. That's perfect. No problems there, because that's greater than 80% drop from the inlet to the outlet, right? That's great. Now, if I'm going down the interstate and I've got 500 part per million coming out of the NOx inlet, but I consistently, while the DEF doser is dosing, have 150 part per million coming out of the outlet, I've got a problem. There's something wrong here, right? It should be much greater than that. But remember, you're only going to see this if the doser is dosing. If that DEF doser is not dosing, then your NOx outlet will be much closer to the NOx inlet than you think it would be, because there's no fluid in there for a conversion, right? If we're not dosing fluid, remember, the fluid is what has the urea. The fluid is what takes the urea, allows it to convert into ammonia, reacts with the oxidation catalyst, which will lower the NOx coming out of the pipe. So without diesel exhaust fluid, or without the correct diesel exhaust fluid, you're not going to see a good conversion, okay? That's why that's always like the number one step that I take, is check that conversion, because it's super cheap, it's super easy. It takes very little skill and very little time. And a lot of times that could be your problem. So always check that DEF fluid first. Now, if I'm driving and I'm checking my NOx efficiency, and my NOx inlet, let's say my NOx outlet's 200 part per million and the DEF doser's dosing, that's too high, right? If I have 500 part per million coming out of the NOx inlet, it is. But what if I have an engine-related issue and I have, say, 1,600 part per million coming out of here? This looks like it would be too high, but it's actually not, because something up here is catastrophically wrong. We shouldn't have 1,600 part per million going down the interstate at a steady rate of speed with the cruise set. Now, if you were pulling a hill, the EGR valve closes, you're at maximum boost, you might see it that high. It's possible. And that's why you need to do a steady rate of speed. That's why you need to have that mid-duty cycle, okay? So if I had 1,600 part per million here and I had 800 part per million coming out of here while the DEF doser is dosing, guess what? That's a 50% duty cycle, right? That's a 50% loss of efficiency, or 50% drop. But I'm not sad about that, because something's wrong here. I need to validate what's happening here, then I'll worry about what's happening here. I got to fix what on the engine is creating such a high NOx level. And it might just be the sensor, or it could be the actual engine itself. It's really hard to tell at this point, right? So we have to do some other checks, right? So what I'll do is, first, I'm going to check my DEF fluid, okay? 32.5 plus or minus 1%. Now, once I've validated that, if that's good, the next thing I'm going to do is I'm going to key on and run a DEF system leak test. What that's going to do is see my DEF pump. It's going to see if that's actually making the correct pressure. If my pressure is not being built, if I don't build any pressure, then I either have a bad pump, or I have a suction loss between the pump and the tank, right? So I'm eliminating that issue. So here, the next step I would do is I'd run a key on DEF system leak test, or just turn the ignition switch on and monitor your DEF pump pressure, either one, right? But the DEF system leak test will override that. It'll check for any leaks on the system because it's pressurizing the whole system. And then it's also going to let me know if I'm building adequate pressure, because without adequate pressure, I'm not going to get adequate injection. Again, if I do that and I'm not getting correct pressure, well, then my problem is either my DEF pump or I have a suction loss between my pump and my tank, right? I'm sucking air somewhere, or my DEF tank fluid's frozen, or my pickup tube's damaged, or whatever the case. I can isolate that point of the problem. Once I've done that, if I didn't find an issue, I'm going to do a DEF doser override test. What that's going to do is, again, I'm going to remove my DEF doser, and I'm going to put that into a graduated cylinder, and I'm going to run that test, and I'm going to validate that my spray pattern looks good, that the amount of DEF fluid that's coming out is adequate. If it's not, I'm going to clean the DEF doser. I'm going to reinstall it and drive the vehicle and watch my NOx. If it's good, then I know that that isn't my issue. So the next thing I'm going to do is inspect my decomp tube, and I don't mean you have to remove it. If you can get a light and a mirror, or if you have a borescope, you just want to inspect the decomp tube for any type of dried urea. You don't want a whole bunch of dried up DEF fluid inside the decomp tube causing restriction. Okay, so while you have the injector out, look down in the mounting hole and look for a bunch of really thick dried up DEF. I know that sounds crazy, but it happens. It's a real thing. Okay, so inspect the decomp tube while you have the doser out. Now, if you don't find anything with that, reinstall it. So our fluid is good, our pump is good, our DEF doser is good, our decomp tube is good, right? So now we've validated all of the injection system. We validated the injection system as getting fluid from the tank into the SCR catalyst, right? Perfect. Now, once we've done that, now what we have to do is figure out how bad is this NOx conversion? Is it genuinely bad? Is it a sensor problem? What's the issue? So then what I would do is I would run a regen. And I'm doing that so I can get my exhaust temps good and hot so I can start to monitor my NOx sensors. Okay? Now, once I run the regeneration, now I'm going to drive the vehicle, run the machine, whatever you're doing, okay, if it's equipment, whatever. While I'm driving the vehicle or running the machine, what I'm going to start looking for are two things. Once it's good and hot and I'm driving it, I'm going to make sure I'm monitoring my NOx inlet sensor, my DEF doser dosing quantity, my NOx outlet sensor. I'm also going to want to monitor all of my basic parameters like boost pressure, fuel pressure, things like that. But I'm also going to monitor my EGR valve position. Once my EGR valve begins to open, I'm going to start looking at my DEF doser. I'm going to monitor when the DEF doser comes on. Now, when the DEF doser comes on, once it starts to dose, that's when I'm going to start looking at how much of a drop do we have from the NOx inlet to the NOx outlet. Again, if I'm driving it and I'm around 500 part per million, I want to see 100 or less coming out of the outlet. If I don't, if it's, say, 500 on the inlet and 200 on the outlet, well, that's too high. That's 60%. That's not enough reduction. I've got an issue, right? But up here is my key indicator that it's probably not my engine, because this NOx reading is good enough. It's good. It's good enough. This isn't. The NOx outlet is not good enough. Okay? So, if that's the case and my NOx inlet's in spec, I'm going to run one more test upon return. If my NOx inlet is abnormally high and my NOx outlet is abnormally high, then I'm going to go to my engine and I'm going to figure out what on my engine is not working correctly. Is my air-fuel ratios messed up? Am I loading the cylinder with fuel? Are my valves way out of adjustment? Is my EGR not working correctly? What on my engine is not performing, causing that value to be too high? right? Now, again, when I return, if I had roughly and I say roughly because, this number is going to vary a little bit, but if I had roughly 500 part per million on my NOx inlet while driving it, and my DEF doser was dosing, remember it has to be dosing, EGR valve is opening, and I had greater than 100 here, then now I need to figure out what's causing it. Again, my engine's not scaring me because it's pretty close. It's pretty good, right? But the conversion's too high, right? There's not enough of a change there. So what I would do is this next step. I would disconnect my electrical connector to my DEF doser. Okay? So disconnect DEF doser. I'm doing that because I don't want DEF fluid to be introduced into the assembly while I run this next test. What I do is I'm going to set the engine at 1200 RPM. And I'm going to set it at 1200 RPM for 15 minutes. So PTO, set your PTO, whatever you got to do. Get it at 1200 RPM for 15 minutes with the DEF doser disconnected. Now at this point, you're going to see probably somewhere around 200 to 300 part per million on the NOx inlet. Somewhere around there, okay? And by disconnecting the DEF doser, I can no longer dose DEF fluid into the assembly. And if I can no longer dose DEF fluid into the assembly, then no conversion is really going to be taking place inside of my catalyst. You might get a very light conversion, right? A very small conversion, because there are metals inside of the catalyst that will convert. So you might get a very slight conversion, okay? But it won't be massive. So if I had roughly 300 part per million coming out of my NOx inlet, then I'm expecting roughly 250 to 350 part per million on my NOx outlet. I'm within 50 part per million of my inlet. If I do that at 1200 RPM with the DEF doser electrical connection disconnected, after 15 minutes, if my NOx outlet is within 50 part per million of my NOx inlet, then I just validated that both of my sensors are reading correctly. Okay? Now, if I did that and I had, say, 100 part per million on the outlet or 600 part per million on the outlet, that's a pretty good indicator that my sensor's not working right. Okay? Your NOx inlet should be around 300. So that's what I generally vary off of. If my NOx inlet is around 300, 250, 325, somewhere in there, my NOx outlet should be within 50 part per million of that. If it's not, then I'm going to replace that sensor. Either one, whichever one seems drifted too high. That's called a NOx sensor drift test. We're validating the sensors, okay? It's a quick way to make sure they work, because there's no other good test for it than to let them validate each other. And I'm going to tell you, most manufacturers have it to where if you do your NOx sensor drift test and they're not within 50 parts per million, most manufacturers recommend you replace both at the same time. Now, I'm not going to say that I did that, but most manufacturers agree if one's biased, replace both. Now, if I check it, after I've checked all my injection system, my engine operation, I've done all of these tests that we've talked about. If I have 300 part per million on the NOx inlet doing the NOx sensor drift test, 1200 RPM, DEF doser disconnected. If I've got 300 part per million on the NOx inlet and I have 275, or let's say 275 part per million on the outlet, then I'm within 50 part per million of each other, right? This tells me my sensors are working. I've driven the vehicle. I've validated my NOx inlet's not too high. I've already gone through my SCR side of the system. If I've done all of that and I got to this point, There's only one component that's left, and that's your SCR catalyst. But it's really important that you go through all of these steps that I talked about and validate your engine's health, validate your inlet and outlet NOx sensor, validate your DEF doser, validate your pump, validate your fluid, and then that leads you down to the one component that's left. SCR catalysts are expensive. They're very expensive, so you don't want to just replace one because you have NOx conversion. Now, are SCR catalyst failures common? They are. They're not super common, but they're common. But so are all the other things that I've talked about today. The trick is you don't want to replace a $3,000 up to a $12,000 part. Like when you start getting into Detroits, when you're dealing with the one box, if you have a failed catalyst, then you have to replace the catalyst and the DOC assembly. It's all welded together. The DPFs can be serviced, but everything else is one unit. So if you think you have a bad SCR catalyst, that's a $12,000 part. So thinking the catalyst is bad isn't good enough. You need to go through these steps to prove the catalyst is bad. Okay? So again, going back to these steps here, before you get too deep, start with the basics. Start by inspecting DEF concentration, 32.5 plus or minus 1%. Perform the DEF system leak test. Maximize the system pressure. Watch your pressure. Make sure that you don't have any leaks. Make sure that your pressure is adequate. If pressure is not in spec, then what I did was perform a vacuum test on the inlet of the pump. That would tell me if I'm getting enough suction. You'll have to make some little tooling to do that, where you can hook a suction gauge up between the DEF tank and the pump suction side. But basically, you should be pulling more than 8 inches of vacuum on your pump, right? So that just validates if the pump can suck enough, right? So if you're not getting enough suction, then that's likely a pump issue. If the pressure is good, then you have enough suction. You don't really need to go there, okay? Move to the doser assembly if you have adequate pressure at your pump. Now remove the DEF doser, inspect for clogging, verify the decomposition tube is not severely plugged. This is severely plugged right here. This is real, okay? This really happens. You are not going to get a good DEF concentration reduction if you have this. So perform that DEF injector override test. Inspect for proper spray pattern. Make sure that it meets OEM specified flow. Collect fluid in a clean, suitable container. If the DEF doser and decomp tube are clean, it's time to test drive and monitor the SCR inlet and outlet. Depending on manufacturer, there may be an SCR performance test available. Sometimes there is, sometimes there's not. If it does have an SCR performance test, that's great, because it'll actually run the SCR test for you and tell you what components it thinks is wrong, is failed. Most of them don't. So if that's the case, you need to start driving the vehicle, moderate duty cycle, make sure that the EGR valve is opening, make sure the DEF doser is dosing, and then you should see that 80% or greater drop in reduction, right? So when the doser is commanded on, you should see your outlet NOx levels start to drop. The closer to zero, the better. Most will read in double, low, or triple digits when dosing. Greater than 80% on most vehicles, 70% on few manufacturers. If the outlet is not dropping and the inlet is in spec, then it's likely you have a failed outlet NOx sensor or failed SCR catalyst. So perform that NOx sensor drift test. Verify if the NOx sensors are reading properly. Remember, disconnect your DEF doser, run it at 1200 RPM for 15 minutes. Monitor your NOx inlet and outlet part per million. They should be within 50 part per million of each other. One last thing I want to say is derates are another common issue. When you have SCR-related derates are for information only. So when you have a derate, you should not troubleshoot the derate. You should not try to clear an active derate. What you should do is try to figure out what's wrong with the vehicle, run a regeneration after you think you have repaired the vehicle, and then that derate should go inactive. Some derates will require an after treatment reset, so you may have to go into your component testing or your advanced DCM data or your settings tab on Texa, whatever software you use where your resets are located, and look for SCR or after treatment resets. Perform the reset. Basically with derates, with SCR derates, torque reductions, you want to make sure the problem's fixed, and you really want the derate to go inactive before you try to clear it. If you try to clear an active derate, sometimes that active derate will lock itself into the module and require ECM programming to repair it. But derates are information only. They're just telling you something's wrong. We reduce the torque and the horsepower. That's all it is. Okay? So this is the point where if you have any questions, I'll be more than happy to answer them. So just go ahead and send them on over, and we will go from there.